Okay, everyone, let's get started with 5-20. So remember, you should have a tab open to this problem in the ebook. This is lesson 5.12, and we're on 5-20. So it says to graph y equals x squared minus 8x plus 7 and fully describe it. So that is a quadratic equation. So I recommended that you have a full sheet of graph paper for this homework, and you could put this graph at the top, and then there's another problem, 524, you could fit that on the bottom. So I recommend you put your x-axis, oh, you can kind of see where it is on my page. It's probably about 15 squares, 15 units down from the top. And then I put my y-axis a little bit left of the center, just because I know what this graph is going to look like. And let's just start with a table. So our equation is y equals x squared minus 8x plus 7. So let's put a table on the side here with x and y. And I happen to know what this one's going to look like. You could use Desmos and type any equation in there to get a sense of what it looks like, and that's how I know. That's why I'm starting with 0. So we're going to start with 0 and go to 7. So I'm going to do the work for this on a separate sheet of paper. I'm going to take the x value, substitute it in. So f of 0 would be 0 squared minus 8x plus, 8 times 0 plus 7. So 0 squared is 0, minus 8 times 0 is 0. So that's going to be 0 minus 0, which is 0, plus 7, which is going to be 7. Remember, order of operations, you're going to do your exponents, then you're going to do your multiplication, then you're going to add and subtract from left to right. Okay, let's do f of 1. So 1 squared is 1, minus 8 times 1 is 8, plus 7. So 1 minus 8 is negative 7, plus 7 is 0. Okay, f of 2 4 minus 16 is negative 12, plus 7 would be negative 5. Nine minus 24 plus 7, so 9 minus 24 would be negative 15, plus 7 would be negative 8. Four squared is 16, minus 32, 8 times 4 is 32, plus 7, so 16 minus 32, that's negative 16, plus 7 would be negative 9. Five squared is 25, minus 40, plus 7. So negative 15 plus 7 would be negative 8. So if your note went from 7 to 0 to negative 5, oh wait, I think this is supposed to be negative 8. I forgot to put the negative. To negative 9. Now it goes back up to negative 8. So that should be something that we notice. Okay, 36 minus 48 plus 7, so that's negative 12 plus 7 is negative 5. Oh, look at that. Negative 5, negative 5. So what do you predict the next one will be? 49 minus 56 would be 13. Negative 13 plus 7 would be negative, let's see, did I do that right? 7 squared is 49 minus 56, so negative 13 plus 7 is negative 5. No. What did I do wrong? I said 13. 49 minus 56 is negative 7 plus 7 is 0. Okay, so as you can see, we've got the same number showing up because it's a quadratic. It's decreasing and then it's increasing. So in the future, you're not going to have to do all of this step by step, but I think it's good to do the first few, one here or there, to reinforce where these numbers are coming from. So we have the 0.07, 1, 0, 2, negative 5, 3 was negative 8, 4 was negative 9, and that's when it started increasing again, and we started seeing those numbers repeat. So 0, 7 is our y-intercept. We're going to write some things on here. Let's go ahead and put y-intercept. And then we've got 1, 0. That's an x-intercept. And we're going to have two x-intercepts. So let's hold off on writing that for a second. 2, negative 5. 3, negative 8. 4, negative 9. And then 5 is negative 8. 6, negative 5, and then 7 is 0. Okay, so I usually, when I'm sketching these, I sketch the bottom of the curve or the top of the curve first, and then I kind of go from there. It's okay if it's not perfect. Okay, so let's label our x-intercepts, and let's see. I'd like to grab a highlighter. If you have a highlighter at home, go ahead and get it. Okay, let's highlight those x-intercepts. So 1, 0 and 7, 0 are my x-intercepts, and those show up here and here. Okay, we've got our vertex at 4, negative 9. Let's go with that. And we do have a line of symmetry. Line of symmetry is going to go through this vertex. I guess I could use my straight edge here, make it look a little bit better. So let's write line of symmetry, and the equation of that line would be x equals, and all of the points on this line are going through 4. 4, 0, 4, 1, 4, 2, 4, negative 1, 4, negative 2, and so on. This is the line x equals 4. Okay, opens upward. I would say that we have fully described that graph. Okay, moving along to 521. This may seem a little strange, but there's a reason we are doing this. What is special about the number 0 think about this as you complete the parts below. Okay, so let's start with A. Oh, this is all part A. Okay. So 0 plus 3 is 3. Negative 7 plus 0 is negative 7. 0 plus 6, 6. And 0 plus negative 2 is negative 2. When you add 0 to a number, you get the same number. So what's special about 0? Write a sentence that begins with when you add 0 to a number. It does not change the value of the number. Okay, part C. Julia is thinking of two numbers, A and B. When she adds them together, she gets a sum of B. Does that tell you anything about either of Julia's numbers? Okay, so we're going to write this out. A plus B, she's adding A and B, and she's getting B. So that means A, therefore A must be equal to 0. If I'm adding a number to B and I'm not changing the value, then this number that I'm adding must be 0. Okay, part D. Same two numbers, but this time we're multiplying. So we're calculating this was the sum. Now we're calculating the product. 3 times 0 is 0. Negative 7 times 0 is 0. 0 times 6 is 0, and 0 times 0. So we're going to complete this sentence. When you multiply a number by 0, the answer is 0. Okay, so part F, Julia's thinking of two numbers, A and B. When she multiplies them, she gets a product of 0. Does that tell you anything about either of Julia's numbers? Okay, well, she's multiplying A and B. She's getting 0. That means either A equals 0 or B equals 0, or A and B equal 0. Okay, now you might have been thinking, what was the point of that? It will become clear very soon. Let's move on with 522 for now. While shopping at his local home improvement store, Chen notices that the directions for an extension ladder state this ladder is most stable when used at a 75-degree angle with the ground. So right there you should be thinking, what is this going to look like? It's a ladder and it's got a 75-degree angle with the ground. He wants to buy a ladder that will reach a height of 26 feet to paint a 2-story house. how long does his ladder need to be? Draw a diagram, set up an equation, show all work. Okay, so we have draw the ladder, and the ladder is creating a 75-degree angle with the ground. Okay, and he's painting a 2-story house. So we know it's going to look like a right triangle, right? Okay, then it said he wants to buy a ladder that will reach a height of 26 feet. So my height is 26 feet. Which one is my height? The height is always perpendicular to the ground, so the height would be right here. And we are trying to figure out how long does the ladder need to be. So we're trying to figure out the length of the ladder. Is this the length of the ladder? No, the hypotenuse is the length of the ladder. So this is what we're looking for. So this is going to be I have and I need. And I'm going to start with my arc. Draw my arrow. This is my opposite. This would be my adjacent. This would be my hypotenuse. Hypotenuse is always my longest side, the one that's across from 90 degrees. So I have my opposite, and I need my hypotenuse. Now, you don't have your posters at home. You need to know what opposite and hypotenuse are. This is where that, it's called the mnemonic SOHCAHTOA, comes in handy. So I know how to spell that out, and if I forget, I can say the word SOHCAHTOA. And then I see opposite and hypotenuse, that goes with sine. So this is going to be sine 75 degrees equals my opposite over my hypotenuse is going to be 26 over, we'll say r for hypotenuse. Put a 1 under sine of 75, cross multiply, so I get sine 75 degrees times r equals 26. I'm trying to get r by itself. R is being multiplied by sine of 75, so I'm going to divide both sides by sine 75 degrees. So I get r equals 26 over sine 75 degrees. And we can just see if that makes sense in terms of the length of a ladder. So I got 26.9 feet for the length of the ladder, which sounds reasonable. Okay, hopefully that was pretty easy. Should be pretty good at those by now. Let's look at 523. Looks like we're going to be doing some matching. Match each table of data with the most appropriate graph and then briefly explain how you know the graph matches the data. Okay, so here we have a temperature in an oven when cooking a roast. So the temperature is increasing. In 5 minutes it goes from 70 degrees to 200 pretty quickly. Then it goes up to 300 in another 10 minutes. Then it levels off at 325. So we're looking for something that's increasing pretty quickly and then leveling off. So all of these are increasing in the beginning, but I would say we can rule out number 3 because this is increasing at a constant rate and then it's decreasing, so it's not going to be 3. This is increasing very slowly and then it increases really fast and then levels off. So I don't think it's going to be number 4. these two are increasing. This is increasing at kind of a slow rate, and then it starts to accelerate the rate that it's increasing. Here it's increasing kind of quickly and then leveling off. This one continues to increase. So that means A must go with graph number 1. So in your notebook, you would just write A. So for 523, let's write a little, maybe for A is graph number 1, because it increases at an increasing rate, then levels off. Let's say that. Okay, for part B, the time needed for an athlete to run a certain distance. So for 100 meters, it takes the athlete 12 seconds. For 200 meters, 25 seconds. So that's almost increasing 12 seconds per 100 meters. Then at 400 meters, it's a minute and 10 seconds. So it's not quite increasing at the same rate per 100. It's not going up 12 seconds per 100 meters because 200 meters was almost 30 seconds. So if you double that, you would think you would get like roughly double the time, but it's a little bit over a minute. Okay, and then if you double that amount, it's doubling this amount plus a little bit extra. So I'm looking at this and I'm seeing, okay, it's taking the athlete more and more time to run the distance. So the rate is increasing, but it's not, we can rule out graph 3, nothing's decreasing here. So it's got to be either 2 or 4. So the time that it takes the athlete to run the distance is getting bigger and bigger, and it seems to be that that rate is slowing down a little bit. So I'm going to go with graph number 2, because here it's kind of increasing very rapidly in the middle, so maybe at a certain distance, but then it's leveling off the time it takes to run a greater distance. Well, that doesn't make sense. As the distance is increasing, the time it takes this athlete to run keeps increasing. So let's put for 523 graph 2, because as the distance increases, the time it takes to run that distance increases. Okay, 524 is going to require some graph paper. Oh, there's my pencil. Okay, for 524, let's do our X and Y axis towards the bottom of that sheet of graph paper. And it says to graph the 3 points. So you've got A is -1, -1. B is 3, -1. And then C is -1, -2. Okay, so we've graphed these points and they form a triangle, plot triangle ABC. So let's go ahead and graph that triangle. Part A says to enlarge, to dilate triangle ABC from the origin using a scale factor of 3. Name the image A prime, B prime, C prime, and list the coordinates. So if we enlarge by a scale factor of 3 from the origin, the nice part is if you're enlarging, dilating with a center at the origin, you can just multiply all of those coordinates by the scale factor. So let's just go ahead and write the coordinates on here. This was -1, -1, and then B is 3, -1, and then C is -1, -2. So if I'm enlarging by 3, my new point is going to be at -3, -3. This is going to be at 9, -3. So that's B prime. This is A prime at -3, -3, and then this would be at -3, -6. So let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6. So you're creating a similar triangle. When you do a dilation, that means that all of these angles are going to be the same and the sides are going to be in proportion. Whatever you do to get the length of go from one side to another. Uh-oh, something looks off. Did I do that right? 1, 2, 3, 4, 5, 6. Yeah, 9, -3. Okay. Kind of looks funny. -3, -6, and then this one was -3, -3. Looks a little off, but I think it is right. Okay, part C, or part B, rotate A prime, B prime, C prime 90 degrees clockwise to create A double prime, B double prime, C double prime. Okay, so if you've got even another sheet of tracing paper or another sheet of paper to put on top of you may not have tracing paper at home, but maybe even if you have just another sheet of paper, I'm going to trace A prime, B prime, C prime. And then it said to rotate it 90 degrees clockwise about the origin. So I'm going to put a little XY axis right here, put my pencil on the origin. 90 degrees clockwise would put me right here. So the new A prime is now at, instead of -3, it's -3, +3. Just going to write it on the tracing paper for now. And then B prime, instead of it being at 9, -3, it's now at -3 and negative, what is that? Is that -9? Okay, just made it on the paper. So -3, -9. And then C that's B double prime, C double prime. The new C double prime, let's see, that was at -3, -6. Now it's at -6 and +3. Okay, so 90 degrees clockwise, what effect did it have? Well, the x coordinate is now a positive, or that remained the same for A double prime. Here, let's just go ahead. But the y coordinate is now positive. And then for B double prime, they switch places, and this is now, and then C double prime, this is still negative, but this is now positive. Okay. And then last, it says if ABC is translated so that the image of point A is at 5, 3, where would the image of point B be? So if it's translated, so the original triangle, which was this one right here, if it's translated so that A is at 5, 3. 1, 2, 3, 4, 2, 3. Okay, so if this moves from here to here, they want to know where is B going to be. Well, if A moves 5 right, or not 5 right, A, if it's at 5, 3, this is a little preview of something we'll be doing later. So then A moved 1, 2, 3, 4, 5, 6 to the right, and up 1, 2, 3, 4. So then B is also going to move 6 right and 4 up. So if I do that, I would get 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And that would put me at, let's see, this was 5, so 6, 7, 8, 9, 3. A lot going on with that one graph, but some good review there and a little preview of transformations, which actually a lot of you have done it on Khan already. 525, a hotel in Las Vegas is famous for its large-scale model of the Eiffel Tower. The model, built to scale, is 128 meters tall and 41 meters wide at its base. If the real tower is 324 meters tall, how wide is the base? So we're just dealing with similarity here. Okay, we've got a model of the Eiffel Tower. Let's see, let me draw that a bit smaller. Okay, and it's 128 meters tall, 41 meters wide, and then they tell us that the real tower is 324 meters tall. They want to know how wide it would be at the base, so I'm just going to set up a proportion that 128, and I could do 128 over 4 equals 324 over x. You could do it that way, or you could do 128 over 324. 128 is to 324 as 41 is to x. Whatever I do to 128 to get 324, I'm going to do the same thing to 41 to get x. You could do that with the scale factor. without setting up a proportion. So whichever way makes the most sense. So 128x equals, let's see, 324 times 41 is 13284, and then I'm going to divide by 128. So x is about 104 meters wide at the base. You could have just said, okay, what's 324 divided by 128, and then multiplied that by 40. Or you could have set up a proportion differently, 128 over 41, 324 over x, and gotten the same answer.